I.O.T, powering the digital economy. Brought to you by Schneider Electric.
Two 250 years on from the start of the first industrial revolution, we're now embarking on the fourth. It's characterized by innovations in robotics, AI, 3D printing, and the Internet of Things, I.O.T, and the integration of those technologies into the production process. The fourth industrial revolution is changing the manufacturing landscape around the world. But how are manufacturers, particularly in the B2B field, responding to those challenges and opportunities? In this programme, we'll visit a long-established technology company offering an artificial intelligence platform to its B2B partners. We'll see how a disruptor company is using additive technology to revolutionise prototyping and the production of parts. We'll talk to an expert about the regulatory issues affecting manufacturing companies. And looking into the future, how will digital technology change B2B manufacturing yet more? And what effect will it have on society? IBM has been one of the leaders of computer technology ever since it was founded back in 1911. It now operates in 170 countries, and I'm outside its London headquarters. Andy Stanford-Clark is IBM's Chief Technology Officer in the UK and Ireland. He's also an inventor, holding more than 40 patents. I asked Andy about IBM Watson, the augmented intelligence platform powered by data, which IBM offers to manufacturers and other industries.
5 years ago, a computer called Watson, about the size of a room, won the Jeopardy panel game in America. And Watson was then a big computer dedicated to a specific task. But after that, we broke the Watson capability into lots of little pieces called services, and we put them in the IBM cloud so that people can now access the part of it that they want. So Watson is really our platform that allows you to have access to image recognition, voice recognition, language translation, pattern matching, all the different types of analytics you might want to use. You just access the part that you want. That's called Watson.
And why is it called Watson?
It's named Watson after IBM's founder, Thomas J. Watson, who founded IBM 100 and something years ago, and we thought it was appropriate to name it after him.
What actually, in concrete terms, does Watson offer manufacturers?
So a manufacturer with lots of sensors on their production line machines, which IBM doesn't make the sensors, we just collect the data and help people analyze it. The Watson capability is taking that data, putting it in the cloud, and then analyzing it to get actionable insights from the data. And a good example of that would be that we've got a system called cognitive visual inspection, which allows, say, a car manufacturer to train a high-definition camera on the paint shop of where a car is being sprayed and be able to look for defects, even smaller than the eye can see, because it's a very high-resolution camera, while the car's being sprayed, and that can save hundreds of hours of inspection time, and it obviously improves defect rates and throughput.
There's lots of applications here. What are your main partners that you're working with?
So we're working with quite a lot of companies who make machinery. We're working with Schaeffler, a company in Germany, that makes sort of big industrial assemblies. For example, the carriages on railway trains, for example, and they're building what we term a digital twin. So it's a digital model inside Watson of the physical system, and they feed the digital model with data from sensors on the real system, and then they can then sort of prod about on the digital model and ask what-if questions. What if we run it for twice as many miles before we service it? What if we change the tension on this bearing or something? And they can do those what-ifs on the digital model before they have to risk anything on the physical system.
Does that enable companies to do sort of preemptive maintenance, so they can spot a problem before it happens?
Yes, that's one of the areas where Internet of Things has really helped in the industrial space, is to be able to predict what's going to happen, what's going to fail, based on past history. And we're working with Kona, who makes lifts and escalators, to make sure that their lifts stay in production. So you should never have a broken lift, or never get stuck in one, hopefully, because the lift will have been sending data back to say, okay, last time this particular sensor reported this reading, then 2 weeks later this particular thing broke. We're doing some work with acoustic monitoring as well. So you actually effectively dangle a microphone down the lift shaft, and you'll listen to those creaks and groans and grumbles, which when we get in the lift we go, something wrong with this lift. Well, now the computer, Watson, can say, something wrong with this lift, and call out an engineer before it actually breaks. So we called it I.O.T. Acoustic Insights. So anything that makes a noise, which is most things, washing machines, compressors, pumps, cars, by analysing the spectrum of sound and profiling it against known sounds and known good sounds and known bad sounds, can be used to predict all kinds of things.
So the computing system is reliant on the sensors. Are these very large bits of equipment?
The sensors themselves tend to be quite small. Here's an example of one. This measures all sorts of different orientation in space and then accelerometer readings. That could be fastened onto something, has a power supply and a radio transmitter that transmits the data to a base station, which then transmits it to the IBM cloud, where it's then stored and analysed by Watson.
You're clearly, with these sensors and others, collecting huge amounts of data about anything. How difficult is it to mine that avalanche of data for actually useful insight?
This is a really big problem, because there's a risk that you'll drown in a sea of data, and the trick is to turn data into information into knowledge, and then knowledge into actionable insights. And what we sometimes do is move all the data to the cloud and analyse it there. What we're increasingly doing is doing processing at the edge, so down near the sensor. So when it gathers the data, it actually filters a lot of it out, looks for the salient facts, and then sends those salient facts up to the cloud just means you haven't got to transfer so much data, and you can do the analysis much more quickly.
And I think people will be really engaged by the sort of promise of what you're offering, but are you able to offer those companies actual figures saying it improves efficiency by X amount?
Yes, the business case for IoT, because we've got a large sort of library, a large repertoire of clients who are already in production with this technology now, we can show them examples from either the same industry as them or a different industry to say, when this client did this, they achieved these kind of savings. And things like predictive analytics, very often the ROI is dramatic.
Return on investment.
Yes, you get your money back within a small number of months because of the huge savings in maintenance costs, as opposed to having to go out and do emergency fixes to things.
IBM is offering a solution to manufacturing companies which can transform processes and operations throughout a factory. Well, I'm off to find out about a company which is disrupting the way products are actually made. Stratasys is a US company which is a pioneer in the field of additive technology, otherwise known as 3D printing. And I'm here at the headquarters of the McLaren Formula One team, which is one of Stratasys' partners. Scott Sebchik is Vice President of the Manufacturing Solutions Business Unit at Stratasys. He's worked with Stratasys for 4 years and has a background in aerospace engineering. Tell me about the technology that you've developed.
Stratasys has really two core technologies within the overall additive manufacturing or 3D printing environment. We have a technology called fused deposition modeling, which we originated almost 30 years ago. It's a technology in which we take durable thermoplastic materials and we extrude them layer by layer to create a part that is able to be used for applications ranging from prototyping to tooling to production parts. We have a second technology called PolyJet. PolyJet is also an additive technology, but in this case we're blending different materials droplet by droplet to create very beautiful, colorful, complex parts that are ideal for advanced prototyping applications.
Scott showed me examples of the way these two technologies are used by McLaren.
So what we're looking at here is a steering wheel for an F1 vehicle. What you have on a steering wheel like this, there's a lot of different controls, a lot of different buttons and knobs. So being able to print at one shot something that is able to really show the look and the feel, the parts that are hard, the parts that are soft, where the buttons are, where the colors are, and be able to then put that in the driver's hand, get feedback. What do they like? What don't they like? What needs to be moved? This allows them to move very quick in creating a final design rapidly and then moving into production without a lot of iteration.
So in one print, you've got all these different colors and lots of different function buttons as well.
Right. So the PolyJet allows us to go very quickly with design. FDM allows us to go very quickly with manufacturing. So what we have here is a composite part. Composite materials are one of the ways that F1 vehicles are designed to be so lightweight. As you can see, this is a very complex shape. So to create a mold for a part as complex as this would take a lot of machining and a lot of work. This is actually a 3D printed mold for producing a part like this. So this is assembled. There's a number of different pieces printed together here, but you then are able to print this complex shape very quickly overnight that then you can take into the autoclave to cure your composite part on the printed tool.
So who are the main customers you're working with?
We actually have over 18,000 customers, so we work with a wide variety of different industries and different types of customers. Some of our most significant when it comes to manufacturing tend to be in the aerospace industry and the automotive industry. So Airbus and Boeing are both partners that have adopted our technology.
At McLaren, there's a room full of 3D printers. What advantage does 3D printing offer more generally to manufacturers?
With additive, we're only using the material we need to create the part. You're saving tremendously on the material, on the energy, and on the time to produce. When we look at a lot of the tooling applications, such as jigs and fixtures on a factory floor, where what's really being gained there is advantages in cycle time. In some cases, we'll save just seconds in an assembly process, but in a high volume industry, those seconds can add up to weeks and months of labor that's saved in the process. Being able to shift from an inventory-based model to a production on demand model where you're producing that part when you need it, where you need it, has tremendous savings.
So briefly outline your company's business model when you're trying to build these sorts of business-to-business relationships.
Stratasys at its heart is a technology and product company. We've created new technologies, for the additive manufacturing space, and we deliver those systems and we deliver the materials for those systems throughout industry to our customers. We've also expanded on that from a services standpoint to be able to deliver parts to our customers where that's how they would prefer to interact with the supply chain, being delivered parts rather than capital equipment, as well as services more of the expert nature, consulting, application engineering, to really help our customers learn how to adopt the technology and accelerate their ability to adopt.
And is this sort of technology really only applicable to this very high value, low volume type model?
The fit is best in high value, low volume spaces today, but we're seeing that expand quite dramatically. So we see, for example, in commercial aircraft, we see aircraft parts being printed by the hundreds and in some cases by the thousands. So the volumes are certainly much more than just one-off parts at this stage in the progression of the technology.
Now, how significant a technology is this in enabling the fourth industrial revolution?
When we talk about the fourth industrial revolution, we're talking about the interaction between the digital and the physical. And when we have a technology that allows us to go directly from digital to physical and being able to produce the part from the CAD design, that's really a significant piece. It's a cornerstone of what the digital industrial revolution
You don't think that's overstating the case? A cornerstone of the new industrial revolution?
I absolutely believe that it is.
As digital technologies transform the way things are made, so new standards and new regulations are required. So, in part 2, we'll be examining the challenges that presents to the companies involved and, of course, to the regulators. As the fourth industrial revolution gathers pace, bringing with it radical changes to manufacturing processes, it's imperative that regulations and quality standards keep up. But what are the implications for both B2B manufacturers and indeed the regulators?
I asked Scott Sebchik of Stratasys how 3D printing is regulated.
3D printing itself isn't being regulated. The production applications are always regulated. So aerospace, healthcare, they have significant regulatory frameworks in place already. So Airbus, we began working with them a number of years ago to qualify the FDM technology for production of aircraft interior components. They need to meet regulatory standards set out by EASA and the FAA for safety. Then we need to be able to show those regulatory authorities that the parts will be consistent in their strength. So we've had to push the technology forward to reduce variability and ensure that repeatable production. And as a result, today, Airbus is printing hundreds of parts for A350s.
Data is the key driver of the fourth industrial revolution, but what are the regulatory frameworks around the use of data? Peter Herweck is Executive Vice President of Industrial Automation at Schneider Electric and is an expert on manufacturing.
In the business-to-business environment, there is no clear regulatory framework that is consistent throughout the world. If you compare the United States, for example, where the ownership of data is handled rather loosely compared to the other side of the planet, China, where there is one owner of the data, and that's the government. That's very clear. In Europe, unfortunately, we're not very clear yet on the regulatory framework, and there is really some work to be done on the European Union level.
But in Europe, the General Data Protection Regulation, the GDPR, will be introduced in May 2018, tightening up provisions around the way personal data is used.
The GDPR, I think is the first step into the right direction, but we need to enlarge the framework to give security to the manufacturers and to the end users, and also companies like ours who deal with the data on behalf of the customers.
How is IBM addressing the GDPR?
We've worked very closely with our clients over a number of years on the Data Protection Act and now the GDPR regulations. Essentially, if you design your system to be secure from the beginning, then these new regulations don't come in anything as a surprise. If you're taking an ethical approach to looking after your clients, your customers' personal data, and you'll store it in secure databases and you move it in an encrypted fashion, as long as all that's kind of built in from the beginning, then these new regulations don't really hold any problems.
But what does pose a real problem for B2B manufacturers is cybersecurity.
When talking with our customers about the digitization journey, the second thing that comes up immediately is cybersecurity. Since everything is connected, there is the ability for intruders to come in and manipulate critical infrastructure, manipulate manufacturing processes, for example, in food and beverage, or in pharmaceuticals. How critical is that? So it's a real concern, and what we need to do is offer cybersecurity or defense in depth, what it is called in the industry, starting with real cyber-secure products and then work our way up into the operational network in the manufacturing plants.
How much of an issue is cybersecurity for Stratasys?
Cybersecurity is a very important concern as we move from prototyping to manufacturing. When we look at manufacturing, especially as we go larger and larger scale, the interest is in distributed manufacturing. How do I have printers every location where I'm going to need them and produce parts on site? And in order to do that, we come back to the Industry 4.0, the digital challenges of distributing that data, ensuring high confidence in that data so that the part you're producing at those different sites is the right part, and you have high confidence that the data used to produce the part is the data that was intended.
We have a big cybersecurity team, both for internal protection but also ready to roll to help our clients. That's a huge part of our business. We find that working with clients across different industries brings us lots of insights into different ways security needs to be tackled, and we have a large array of products that help with actually using analytics to improve security. So we actually use our Watson Analytics on security events, like people logging into a network, network traffic from a device, to say, that's anomalous, that's unusual.
Clearly, regulatory regimes need to stay ahead of all the new technologies which are transforming B2B manufacturing. But Looking further ahead, how will these new technologies change manufacturing even further? And what effect will they have on society? The fourth industrial revolution is beginning to make an impact on all the stages of the manufacturing value chain. But what changes can we expect in the future?
Scott Sebchek told me about innovations Stratasys has in the pipeline.
But really where we're going with 3D printing in the long term is to bypass tooling entirely and being able to directly print those composite parts. And we've begun to develop new systems like the robotic composite 3D demonstrator, where we're moving outside of that layer by layer production approach and moving to an inside out production approach, so we can align those composite materials in any orientation in order to really optimize the strength we're able to gain from those sorts of materials.
Andy Stanford Clark at IBM thinks voice recognition will become more significant.
Where the power of it will come from is when you get voice recognition in context. So for example, if you're on a manufacturing floor, you might have a conversation with an actual piece of machinery and say, okay, when do you think you might need maintenance?
Because at the moment, we talk to machines. You're talking about a future where the machines really initiate the conversation with us.
Yes, absolutely. And that's quite a big difference, that the machines will reach out to us. They won't interrupt us when we're busy doing something, because they'll recognise that. Well, I think we're going to see machines on production lines that will call for help when they need it. So rather than having to ask each one, a good look at each one individually to spot which one it is that's got the problem, the one that's got the problem will contact you. It might speak to you, or it might send you an email or a text or something, but it'll have the capability of knowing what going wrong means in some sense, and then being able to tell somebody about it.
That technology advances, and as it's adopted more, what sort of implications does that have for society, not just manufacturers, but as all of us as individuals?
It has some interesting implications. So right now, for example, you can go to a nice restaurant and they might be advocating or advertising their locally grown produce, and they do that for reasons of reducing environmental impact, for transporting food from many places. Well, imagine if you went to that restaurant and your fork and your spoon and your plate and your table were locally produced as well. That's an implication of this technology going forward. Production can become increasingly localized as a result of being able to distribute that production to where you need it.
But will people become less necessary to the manufacturing process?
No, I think it actually increases the need for them, because what we tend to see is that, first of all, there are new jobs that go with supporting the operations that have been mechanised, but also what we also tend to see is that when productivity improves through automation, then businesses grow, so you need more people to do all the other jobs that the robots aren't doing. I think a lot of people are glad to be freed up from what they term the 3D, the dull, dirty and dangerous jobs, and would much rather be doing ones which are less repetitive, and require them to think.
So I don't believe actually that we will have a lot of unemployment because of the fourth industrial revolution. There will be a lot of people who work in the area of data scientists. We will need many more software engineers. We'll need many more application engineers. And with that, like in the other industrial revolutions, there's going to be an up and reskilling of people in that respect.
What about the future for 3D printing?
You see it as a cornerstone of the fourth industrial revolution. Is it possible that it's a cornerstone of the fifth as we move production out of the Earth into space? Because surely that's a huge area of potential here. You don't have to take things to Mars. You take a 3D printer and make it on the planet.
I think 3D printing is going to be very key in production in space as we move further into the future. For a number of different reasons. We look at the technologies we have today, and rather than producing the part first and then taking it to space, where we're taking up a lot of space in doing so, we can take just the raw material and take the printer, and then you're not guessing at what parts you're going to need in the future. You're taking something much more small, consolidated, So if you need one kind of tool one day and a different kind of tool a different day, having that flexibility is really key. And then when we go even further, being able to utilize the resources that we find in space, whether on the moon, on Mars, and be able to take those materials that are natural to that environment and adapt those to 3D printing processes. That's where we have a significant advantage in bringing a means of production to an environment where there is none, and there needs to be something in order to create that foothold and start moving us forward.
The fourth industrial revolution is ushering in an era of smart factories and intelligent end-to-end production processes. It's a time of real commercial opportunity for businesses pioneering these advances in digital technology and, of course, for their B2B partners.
I.O.T, powering the digital economy. Brought to you by Schneider Electric.